Bismillah ar-Rahman ar-Rahim. This October 2022, 42 variant question number 6. What a question we have here. Three particles A, B, C of mass 0.3, 0.4 nm kilograms lie in a rest on a straight line, smooth horizontal table. So no friction at all. Okay. Distance between B and C is 2.1, sorry. And A projected towards B with speed of 2. So let's try to write that one. It means the situation is what? There's a particle A, and this is a particle B. Okay, and situation is what? And particle A mass is 0.3, point B mass is 0.4. So A and B. This is a before collision. Because he talk about A and B collision. Okay, so let's try to solve it. This is before, this is after. And he says what here? A is thrown towards B with speed of 2, so this speed of 2. So U1 is equals to 2. And in the beginning I said rest, because all three particles are in rest situation, so U0. So it means very clear. Now after that, after collides B with speed of A, after collides with B, speed of A is reduced to 0.6. So this speed is 2, will become 0.6 and still moving in the same direction. So that is why I kept this arrow. 100% B will move this way and V2 is unknown. And he asking us, show the speed of B after collision is this. So this is my target to prove. Okay, so let's start. What is the formula? M1 U1 plus M2 U2 is equals to M2 U2 plus, sorry, M2 M1 V1 M1 V1 plus M2 V2. Okay, mass into velocity 2 into 0.3, I got a 0.6, and this into 0 gone, no need. So 0.6 into this, I get 0.18, and this into this, I get a 0.4 V2. So this is subtract from here, I get 0.48 and 0.4, wait a minute. 4, not 48, 42. All right, check again. This is a from 0.6. If you subtract 0.18, yeah, 42, and divided by 0.04 V2. So if I divide this answer by 0.4, so our answers turn to be velocity is 1.05 meter per second proved. Done. So he was asking, prove this. Alhamdulillah Rabbil Alameen. Done. Second part is asking, after collision A and B, B moves towards C, which is in a rest situation. B now collides with C. All right. After collision, the two particles coalesce, okay, and have a combined speed is 0.2. So same situation, I will take it. So for example, I think I should take this as a whole diagram copy. I modify some extent. Copy and paste here. Okay, but this time the particle here, not A, here B. I mean, here B, here C. Okay, this mass is, I think, unknown. And this, okay, let me write all these change. So this mass is very clear. Mass of B is, mass of B is 0.4. Okay, and mass of C, how much? M kilograms. Okay, and what is U1? So this will behave as a U1 now, because that last speed with which it will leave here will hit that will become a U1. So this V2 will become U1, so 1.05. And after that, coalesce, so it means they will behave as a one object. they will behave as a one object. They will go together with a speed of v. He said a speed of 0.5, sorry, v equals to 0.5. He given us here. And what a question he's asking us, find mass. So very simple, m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. But situation is there because scalar. So what happens then? Both masses add, so m plus 0.4, and because v same 0.5, I'm multiplying here 0.5. And what other situation? 1.5 into that, so 0.4 times 2, 1.05 plus 0 into that. That is why. Okay, 0.5. Okay, I think 0.5 will divide here. 0.4 times to 1.05 over 0.5 m plus 0.4. So just a matter of typing in calculator, and let me check what answers come. This is becoming 84, and divided by m is a plus. So this is going to subtract. If I subtract, it becomes 0.44 kilograms. So alhamdulillahi rabbil alameen, I believe this is nothing hard. That's it. Okay, this is this question we have, find the time it takes from instant from B to C collides. Okay, it means time watch start from instant when they collide. Okay, and until a collide with the combined particle. Okay, situation is such that I will show you this diagram. This diagram is very important. If you try the question, do the question without diagrams, it is just like impossible. So have a look here all carefully. This is question is tough here. A particle. Okay, and this is A particle. Then say we have a B particle here. And let's say C particle here. Or I think I can drag slightly back, no problem at all. Okay, so this is A particle. This is, I'm writing because no mass not required. I'm writing ABC inside. Okay, A particle, B particle, C particle. Okay, situation number one, this is happening. Number one, so I make it I clear, and he said that gap between, I think so, this part, I will show slightly more because this gap is very important. This gap is given by him is 2.1 meter in the beginning. You can see this one. The gap between BC is 2.1 meters. So gap between B and C is 2.1 meter. This distance is very important. Okay, have a look now. Situation number one, when A is traveling towards B and hit. So they will hit, for example, A. I give you idea. Hold on. I copy and paste here. Copy and paste here. Okay, this is A particle, and when it will hit with the B particle, for example, this situation we have, this is B particle. Okay, after this, what happens? Situation from here to here is again 2.1 meter distance till C. This is very clear approach. Okay. Situation is what after this one situation leave this. Okay, so I will check that B will be, what is the speed of B? Speed of A at this moment after leaving, he said that speed of A after collision 0.6. So this speed is here is 0.6, and speed after B when it left, it was 1.05, and this speed was 1.05. Okay, when they are leaving together. Okay, separating together. So now B will take how much time to reach C, because B hit the collision. That is important. So I'm giving a title here for B. So for B, until hit for example, until it hits C, until it hits C. There's a title. C. So naturally, what's formula? V equal to, distance is equal to velocity, speed into time. Okay, this because no friction at all. So distance is 2.1, speed of the V is 1.05, and time is important to know. It goes down and time becomes 2 seconds. It means that B will reach C in 2 seconds. That's very, very clear. So when it will reach B, then I will start counting. So I want to know that this A will travel how much, because ultimately A will hit the combined particles. So I want to know that A will move how much distance. So for A, after first collision, first collision. So I want to know this thing. So naturally, it will take time, 2 seconds speed, you know. So distance is equal to V into T, and distance I want to find. Velocity of the particle A is, 0.6, and time I just got it 2. So this is becoming 1.2 meters. It means this when situation it happens, this A will travel from here and B will hit. So A will reach where? A will reach somewhere here. 1.2 meters travel, it will finish. This A particle, it reach here. It will travel 1.2 meters, 1.2 meters. And how much? And this is the combined particles now, B and C. B and C are now combined. Okay, B and C are now combined masses. So because at this, when it after 2 seconds, B will reach combined particle and A will reach here. Now my stopwatch on from here. Why stopwatch on from here? He said that find the time when from the instant means time, that time when B and B will collide. So collision happened here, but when the collision was happening, A reached at this point. It means how much distance between these two particles, this combined particle and A particle. If I subtract from 2.1, 1.2 subtract, this becomes 0.9 meters. It means this situation is gone now very clear for us now. I'm going to move to the next stage. This is A particle now, and combined particles are here. Situation is very clear now. Particle B and particle C. If you'll not do this diagram, it's very hard to get it. Okay, now from this situation, the gap is between them is 0.9 meters. Stage number last, what is that? So from here, for example, they meet here. Just imagine the A particle and combined particles reach at this stage, B and C. Example I give you, they meet at this moment. So the distance traveled by the A particle is this. I mean, I make it here, collision is here. And given this distance traveled by A. And this distance is from here till here is traveled by combined particles. COMB means combined particles. So you common sense that distance of the full, look at here, full distance is x by A. This is this. Okay, if I subtract from here to there, I get 0.9 gap. Or I can say that distance by xb plus 0.9 equal to that. Look at here, this distance plus this distance equal to that distance. So I can say even this. So I'm writing here XA is equals to 0.9 plus X combined. Okay, now how to get a distance traveled after that? Because one part is clear, 0.6 speed of the particle A throughout 0.6. So now here I'm starting that. So how many distance it will, because now I can say that. What is distance traveled by the particle A? Because distance formula is V into T. V is point A throughout for this one. So I can say 0.6 into T. And 0.9 is already there. And what is a combined? Combined speed, we know already combined speed after the hitting is 0.5. It is not changing throughout. So again, the same formula, velocity into time, so 0.5 into t, and 0.5 into t come this side, 0.6 t minus 0.5 t equal to 0.9, and here I get 0.1, so this is the time becomes 9 seconds. I hope so. The concept is very clear, but make sure without these diagrams, I think it's very hard to understand and very hard to do the question. So as a teacher, I suggest you please, whenever try this kind of question, so please make sure you must sketch these ideas. Otherwise, you can't solve this question. So I hope so. The concept is clear.